Hello, grade 7, and welcome to session 3 of our lesson, which is angles and lines. Today, we are going to start talking about angles and lines together. So, let's start. What is a transversal? We already talked about the transversal. Let's discover more about this line. The sides of the window are transversals to the top and bottom. Here we have window. These sides are called transversal. The top and the bottom of the windows are parallel, as you can see. So, the transversal is a line that intersects two or more lines that lie in the same plane. So, this transversal cut these two or three parallel lines. Transversals to parallel lines form angles with the special properties. We are going to talk about them. So, if we have any two lines and cut by a transversal, we will get alternate and corresponding angles. Now we are going to discover more about alternate and corresponding angles. If you look at the figure here, alternate angles such that A4 and B2. This is A4. This is B2. Another example about the alternate angles are A3, this one, and B1, this one. Let's see the corresponding angles. We have many corresponding angles. Example, A3 and B3, A4 and A4 and B4, A2 and B2, A1 and B1. What can you deduce? Look, A4 and B2 are alternate angles. A4, this is A4, and B2 are alternate angles. Alternate angles have Z shape. Let's check the corresponding angles. A3 and B3. These two angles are corresponding angles. So what does they form? They form F shape. So corresponding angles make F shape, like this one, or like 7 and like this one. While the alternate angles look like this Z shape or N shape. Property 1. It is used to calculate angles. If these two lines are parallel and they cut by a transversal, here we have XY parallel to UV and they cut by a transversal, this line which is TZ, it's a transversal, then we will get alternate and corresponding angles, but in this case these alternate and corresponding angles are equal. So in this case, example, A3 and B1 are alternating angles. They are forming Z shape. Okay? These angles are equal. Why? Because we have parallel lines. This angle is equal to this angle. It's look like the Z shape, or we can say that this one and this one, they are also forming Z shape. So we can say that A4 is equal to B2, equal alternating angles. But if we want to search for corresponding angles, here is look like the F shape. This is this one. So under the F we have A3 is equal to B3, equal corresponding angles, or look this one opposite. So this one will be equal to this angle, equal corresponding angles. Okay, let's learn more about alternating angles. We said that alternating angles formed when a transversal cuts two parallel lines or any two lines. But if the transversal cuts two parallel lines, then the alternating angles formed are equal. Alternate angles have Z or N shape. So, to have equal alternating angles, we must have two parallel lines cut by transversal, and we have to search for Z or N shapes. So, now let's take more examples about alternating angles. Here we have two parallel lines cut by a transversal. So, we will get alternating angles. They are equal angles. They are very important and used to calculate the missing angles. This angle is equal to this angle. The angles inside the Z shape, this one and this one, they are equal alternating angles. Here and here. Take another example. We also have this one is equal to this one, opposite to Z shape, like the S shape is equal to this one, equal alternating angles. More examples. Look, here we have Z shape, equal alternating angles. Let's take more and more examples. Here we are going to see more equal alternating angles. As you can see, we have two parallel lines and they are cut by a transversal. So we have alternate and corresponding angles. But now we are going to talk only about the alternate angles. We find alternate angles making Z shape. These alternate angles are on the opposite side and at the opposite ends of the transversal that cuts the pair of parallel lines. Look, they are at opposite sides. Okay, and opposite ends. This is at the first end, this is at the last end. So these are two equal alternating angles. Another example about alternating angles, can you find? Yes, these also equal alternating angles. Look at their shape. They are equal in measure. Now, can you identify the alternating angles? Yes, here we have alternating angles A, B, C and B, C, D. They are equal alternating angles because we have parallel lines. Here, do I have alternating angles? Yes, we do ABC and BCD are equal alternating angles. Look here, we also have parallel lines, so I also have alternating angles. Look here, do I have equal alternating angles? They are not equal. Why? Because AB is not parallel to CD. Now the question is, are these two angles alternating angles? No, pay attention. The alternating angles must be on the opposite side. Okay, one here and the second one must be here. So these are not alternating angles, the two yellow circles. So this one, yes. This one, yes. This one, yes. And this one is no. Now let's discover the properties of alternating angles. We said that if we have parallel lines, AB is parallel to CD and cut by a transversal, then the alternating angles are equal. So here I will have ABC is equal to BCD, equal alternating angles. So what can you say about the alternating angles? When we have parallel lines, alternating angles making Z shape are equal. Now let's use the properties of alternating angles to calculate the missing angles. Look here. I want to find the missing angle. Given AB, as you can see, is parallel to CD. How did I know? From the symbols below. So, can you find the measure of angle HCD? Yes, HCD is equal to AHC. Look, we have Z shape. They are equal alternating angles. So HCD is equal to 80 degrees. Now, look at the second figure. Can you find the measure of angle BCD? What do we have? We said that to have equal alternating angles, the first condition, we must have parallel lines. Do I have parallel lines? Yes, CD is parallel to AB and CB is the transversal. So, can you find now a Z shape or N shape? Yes, we have. So, this angle must be equal to this angle. Why? Because they are equal alternating angles. Since AB and CD are parallel, so BCD is equal to ABC equal to 50 degrees. Why? Because they are equal alternating angles. And every two alternating angles have equal measures. Okay, now let's make one more application and find the missing angles using the properties of alternating angles. Given this figure, I have two missing angles, this one and this one. First of all, do we have parallel lines? Yes, ED is parallel to CB. So I have equal alternating angles. Whenever you see parallel lines, we search for equal alternating angles. Search for Z shape. Here I have Z shape. So these two angles are equal. ACB is equal to EAC, equal to 60 degrees. Why? Because they are alternating angles making the shape. Okay, now can you find the measure of this one? Look here. Yes, we also have a similar Z shape. We have DAB is equal to ABC. Why? Forming alternating angles. So what is the measure of DAB? DAB now is equal to 50 degrees. So the measure of ACB here, it's 60 degrees, and the measure of the second missing angle, which is here, it's equal to 50 degrees. How did I find the missing angles? I found them using the property of equal alternating angles. By this, we finished this session. Thank you for watching. Goodbye.